This video is only applicable to electricity monitoring systems sold as a DIY kit. The heat pump monitoring systems or managed systems are totally pre-provisioned with no on-site configuration required. So let's just have a look at the overall of this installation here, and then we'll go into what we're going to monitor. So we'll see we've got the main incomer coming up here to the main supplier fuse. Then it goes through our meter here, through the main switch, into these 100 amp connector blocks. And then we have one set of tails going into this consumer unit here, which feeds an electric vehicle charging point. And then the other set of tails come over here and into this consumer unit here, which feeds all the circuits feeding the house. I've just taken the cover off this board here so we can take a look inside. It's important to isolate the board when we do that. This is turned on here just because I need some lights above me here to make this video, but I will be turning it off before I dive in and start fitting any CT sensors inside here. So I would like to monitor the main grid supply. So to do that, I'll need to put a CT sensor somewhere along the main cables coming in before they split. So a good place to do that will be here. This is actually a CT sensor for the battery storage system that's over there. So I reckon we'll put one of our sensors next to it. And this will need to be a 100 amp CT sensor. I've got here a selection of the CT sensors. This is a 100 amp sensor. This is a 50 amp sensor. And here is a 20 amp sensor. So we'll see, we need the 100 amp sensor to be large enough to feed these 25mm tails through. So we'll put one sensor there that'll monitor the main and the full installation. And I think I'll treat this consumer unit here, which feeds an EV charging point and an outdoor socket all as one, and we'll just call this EV because the outdoor socket, it's sometimes used to charge a second electric vehicle or occasionally for a mower or a hoover, but that energy will be pretty not very substantial. So if I put a CT sensor around this cable here, this one here, which is alive feeding this board, that will then give us a feed for the EV charger. So we need a second 100 amp sensor there. And then if we put a CT sensor around this cable here, that'll give us the consumption of the main house. But in the main house, I quite like to do a bit more granular monitoring. So you can see there's quite a few circuits. All the circuits are labelled there on these little heat shrink labels. So I want to monitor a few things separately. Definitely want to monitor the battery storage. So that is this cable here, and it's on a 20 amp breaker. So we can use a 20 amp sensor around that one. I'll probably also monitor the cooker one. That's not another high load appliance, another 20 amp sensor around that. And probably also the kitchen sockets, the kitchen ring main. So before I mount them on the wall, let's have a look at the various components of the system. So this is the emonPi2, which is the energy monitor and base station. You can see the CT sensors plug into their CT1 to 6. This one can take up to 6 CT sensors. And this has got the base station here, so this can connect via Wi-Fi or Ethernet to the network, to the internet. And then on this side here, we can connect various temperature sensors, and that's where the emonVS voltage sensor connects. And this is that emonVS voltage sensor. This is what provides the unit with power and also provides it with an AC voltage sample via this RJ45 connector. This can either be plugged in with a 3-pin plug. I'm going to use this conveniently located socket here, but it can also be hardwired to a low rated circuit breaker, like a 6 amp lighting circuit, if there wasn't a socket there. So fitting the emonPi would be the easiest thing to do because this is an all-in-one solution. It does the energy monitoring and it's the base station all in one. But to fit this, though, we will need Wi-Fi signal or an Ethernet connection in this location. So we're in a garage here. and so Wi-Fi can sometimes be a bit patchy, and I don't have Ethernet here. In this house, Wi-Fi is not too bad, but I'm actually going to fit an emonTx in the garage here, which, so they see this just doesn't have the base station part. There's no Ethernet socket on it. It's just an energy monitor. It doesn't have a screen. So I'm going to fit this here in the garage, and then that will transmit the data through. I'm going to put the emonPi as the base station in the house, and that'll receive the information from the emonTx via this low power 433 megahertz link. And the main reason I'm doing that actually is because I want the emonPi to be in a central location in the house where I can hardwire it straight to the router, so I don't have to mess around with Wi-Fi, and also it'll be in a central location in the house to be able to receive data from other wireless sensor nodes. So I'm going to scatter a number of emonTx wireless temperature sensors around the house, and because the garage is off on the side, they probably wouldn't be able to, the signal from those temperature sensors wouldn't be able to reach the garage. So clipping CT sensors around these meter tails here, this will be very easy to do and doesn't require opening up any consumer units or anything. But because I want to do more granular monitoring, I'm going to have to install the CT sensors to monitor these individual circuits inside the consumer unit here. I'm going to actually have to clip them around these live cables in here. So obviously this does require taking the cover off, and this is something that we would recommend getting an electrician to help with. So having the CT sensors located inside the consumer unit will mean we're going to have to get the cables from the consumer units out. And consumer units often have these little like knockouts here. So what we're going to do is, I think we'll use that knockout there, because there's a nice bit of empty space in there to bring the CT sensors in. Right, I'm just about to clip on the first CT sensor. An important thing to note when clipping on the CT sensors is on the bottom of the CT, there's an arrow with K and L. So the arrow points towards L, so L is the load and K is the supply. So when we're clipping it onto the main incomer here, we want L to point towards the, towards the house, towards a load. So in this case here, the current is going to be coming out of the switch on the live cable, out of the switch and into that connector. So we want L to be facing that connector. So it's going to go on in that orientation, like that. If you do get it wrong, it just means that the value will be inverted. So if you're expecting, say, when you're importing 1 kilowatt, it should say positive 1,000 watts. If you see negative 1,000 watts, it either means you're exporting or you've got the CT clipped on the wrong way around. Okay, I'm just about to clip a CT around the PV here. And this is where it might get a bit confusing. So on a PV system, which way is the load? Well, actually here, the load will point into the circuit breaker, as in into the house, because we want the energy monitor to measure positive generation when we're generating electricity. It's very important to make sure the CT is properly clip shut. You should hear a click when that little clip clips down there. You want the CT to be nice and closed fully, otherwise you get incorrect readings. So when you plug in the CT sensors into the energy monitor, it's important to correspond the correct CT sensor with the correct calibration channel. So if CT1's been calibrated for a 100 amp sensor, you need to make sure that a 100 amp sensor is actually plugged in. And if you order the CTs from us and specify the CT sensors when ordering, we will have pre-calibrated the unit for you. And I don't know if you can see that, but on the side there's a little sticker showing what channel's been calibrated for what. But it is possible to change that. I'll cover that in a minute here. But you can see this unit here, CT1, 2 and 3 have been calibrated for 100 amps. CT4 has been calibrated for 50, and CT5 and 6 have been calibrated for 20. And to change it, if it's an emonPi, we can change it in the config. If it's an emonTx, we need to actually plug a USB-C cable in under there, where it says USB, plug USB-C cable into there, connect it to our laptop and then use the little web serial config utility. Okay, I've nearly finished the installation here. So we've got the Emon VS plugged in here. This is what will supply power to the unit, and a voltage sample. That's plugged into the RJ45 input on the emonTx5. And then we've got 6 CT sensors plugged in. One for the main grid import, one for this board here, which is EV charging, and one for the main house board. And they're all clipped around the live 25mm tails. And then inside the board here, we've got one 50 amp sensor monitoring the PV, one 20 amp sensor monitoring the battery, and one 20 amp sensor in there monitoring the cooker. So they're those. Down here we mostly have lighting circuits, so I'm not going to bother about them. And just before I put the lid on here, I've just used a little bit of trunking, which keeps everything tidy and gives us a convenient place to store the cable. Just wanted to point out, when we've gone into the board here, we've got a little rubber grommet there, so that the CTs don't cut on the sharp metal as they enter the, you can see it better from that side, as they enter the consumer unit. So I'm just going to clip all this up, make it tidy, and then we'll go and switch it on. Okay, that's all done. So the EnergyMonitor emonTx5 transmitter node is now installed, and we've got all the CT sensors clipped on there inside that consumer unit, and these ones going over to be clipped on at the various points in the tails. Now all that's left is to power it up. We should see a red light inside there, showing that the emonTx is getting power. So I'm just going to put the cover on the consumer unit there, and we'll go inside and go and set up the base station. So I've got the emonPi2 base station powered up, plugged in with the USB-C power supply, and plugged into Ethernet. And I can see it's showing that it's connected and it's got an IP address. If the Ethernet wasn't connected, it would then broadcast an access point and then give me an opportunity to connect to it via a captive portal to then connect it to the house Wi-Fi. But since we're using Ethernet, it's plug and play. As I mentioned earlier, this emonPi2 is not doing any energy monitoring itself. It's just receiving the data via low power 43 MHz RF from the emonTx5 in the garage, and also some emonTH temperature and humidity nodes. Let's go ahead and set up this emonPi. So we've got it connected there. You can see in Ethernet, it's got an IP address. So we're just going to click continue on Ethernet. We're going to log in with default username, which is emonSD and emonSD. All right, now we're logged in, we're going to go to the inputs page. We can see a number of active inputs. Just going to collapse them all. I've got some other wireless sensors which it's picking up some data from. But this is the one we're interested in, which is the emonDB6CT one phase node 27, which is the default node for the emonTx5. We can ignore the data coming from the emonPi2, because remember, we're using the emonPi2 as a base station in this installation. So this data is data that's coming from the emonPi2 itself that's sampling, but we don't have any CTs connected to it. You can see all the power values are next to 0. So let's just ignore those values. These are the data that we're interested in, coming from the emonTx. So we can see it's showing a voltage of 240 volts. The EV P1 is using 4.7 kilowatts currently. We're importing 4.78 kilowatts from the grid. The EV is using 4.5 of those kilowatts. House is using 178. So at this point in time, there's no data login taking place. So to start the data login, we're going to go ahead and log these inputs to feeds using what's known as input processing. So let's start off with the V1, which is the VRMS voltage input. This is a nice, easy one. So we're just going to click on the little spanner icon on the right-hand side here. And then we're going to choose log to feed. We'll choose the default name of V1, but we could rename it here. But I find it easier to rename the feeds later if needed. and we're going to choose the standard interval, which is 10 seconds, and then we're going to click add. So that's created a log to feed input process, and it's possible to add multiple input processes. There's lots of different input processes to choose from, which you use for various things, but for V1, for VRMS, the log to feed input process is the only one that we need. Now we can click save and close on the input process list. And now we can see next to V1 on the input list, we can see a little input process. So then if we go to the feeds page now, we can see we have one feed, which is V1, and it has the current grid voltage as a value. If we click on that feed, it'll open up the graph view. And if we go and have a look right at the end here, we'll see we've got a little bit of data coming in. There's obviously not much to see yet, but you can see the grid voltage fluctuating. The axes of this graph here will scale. So even though it looks like the grid voltage is shooting up, it's only actually gone from 243.5 to 243.7, which is perfectly normal grid fluctuations. So now we'll go back to the inputs list. Now we're going to log the other input to feeds. Because this system has got generation and the battery, it's a little bit more involved than if it was just plain consumption. So we're just going to click on the little spanner icon next to P1 and go log to feed. We'll call it P1 grid. And we're going to log it every 10 seconds. Well, actually, let's call it grid raw, because this is grid import and export. But really we want to be able to differentiate between import and export. So I'm going to create a little input process here called allow positive. Here we go. Allow positive. So this will only allow positive data to come through this input process. Each of these input processes are evaluated in turn. So now we can log this to feed. We'll call it grid import, because that's positive grid. That's created a power feed, but we also want an energy feed. So I'm going to do a power to kilowatt hour and call it grid import kilowatt hour. So that's going to accumulate the energy which I'm importing from the grid. So now we also want to do this for export. So I'm just going to reset this feed to the original using the reset to original input process. So now we're back to the original grid raw feed. So now I'm going to go allow negative, and then I'm going to multiply by -1 to convert the negative import into a positive feed value. And I'm going to log this to feed. I'm going to call this grid export power feed. And then I'm going to create an energy feed for this, power to kilowatt hours. We'll call it grid export kilowatt hours. There we go. So that's the finished input process list. So now we'll close that, and then we'll go to feeds. So now we'll see the feed that we've created. So we've got grid raw, which is showing 6.6 kilowatts, and grid import, which is also 6.6 kilowatts. And you can see grid import kilowatt hours is now accumulating kilowatt hours, and there isn't any grid export. It's now a few weeks later since we installed the system. So let's go and have a look. Now there's a bit of data to look at. So I've arranged the feeds into power feeds and energy feeds on the feeds view. Just put them under different node names to make it a bit easier to see. So we can go ahead and click some of the power feeds. So if we go ahead and have a look at the EV, let's just fill it in to make it a bit clearer. So we can see that's an EV charging overnight. We can then turn on, say, the cooker as well. Let's see if I can find a bit of cooker energy. So that's cooker being used in the evening. Battery charging, fill that in as well. So yeah, battery charging overnight. So you get the idea. You can have a look at granular minute by minute power data. So what about energy data? So the energy feeds are, if we have a look at the grid input feed, you can see it's an accumulating value like that. So it's more useful to look at like daily data. So to convert that into daily data, we're going to select bars. We want to see a bar chart, and then we'll select daily bars, and then delta, which is the difference between each day. Let's fill them and then click reload. So there we go, that's the grid import day by day. So then we could also say stack how much of that grid import is from the EV and how much of it's from the cooker. So we'll check the box next to those two, and then we'll do the same delta fill bars reload. So then you can see the total grid import is in yellow, the EV is in red, and then the cooker is this little bit down the bottom in blue. So you can see on some days the EV is like 3/4 of the house usage, which should be expected. So then once we've made a graph like that, we can then save it. If we give it a name, we call it, let's call this daily. Then we can save that. So next time we go into the graph view here, instead of having to do all that work to make this graph, we can just click on the daily graph. It's also possible to create dashboards by embedding graphs into dashboards or using various dashboard widgets under the dashboard page, or you can use some pre-built apps. A popular one is the emonTx5 apps. So these are application-specific dashboards. The emonTx5, you basically choose a consumption feed, which would be, say, grid import, power feed, and then grid import kilowatt hour energy feed. Enter a unit cost, say 25p per kilowatt hour, and then launch. So now you can see each day, and you can click a particular day and see the power trace for that day. Back to history view, they can view cost. So see how much each day cost, £5 worth on that day. Thank you for watching this OpenEnergyMonitor installation video. If you would like more support, please see the OpenEnergyMonitor community forums, or feel free to give us a ring or drop us an email.